Okay. So the first question is going to ask you what cells are... well, not the right one. This is the wrong one. Hang on. Okay, sorry about that. We'll try this one.
That's not right.
Yes, that's not a right question. It can be a little serious. Okay, we're starting. 78 people are in. Okay, first question. Okay, GnRH is released from what and targets the what? So where are all the releasing hormones coming from? Hypothalamus. All the releasing always come from the hypothalamus. Okay. What type of cells are they going to target in the anterior pituitary gland? Gonadotrophs. Okay. What two hormones are they going to be releasing now? LH and FSH. Okay. The stimulating hormones, follicle stimulating hormone comes from the pituitary gland. Okay. The releasing come from the hypothalamus. And there's only two hormones in the posterior pituitary. What are they? ADH and oxytocin. And how are they released? Via hormones or neuro? Neuro. So it can't be posterior pituitary because they're neurally mediated to be released, not chemically through releasing hormones. Another good one is ovary action. Okay, what's special about FSH? Which one's true? So make sure you know the differences between FSH and LH and their actions and what they do. They are different. Follicle stimulating hormones. In the females, it stimulates the follicles. Males don't have follicles, it creates sperm. Same thing, making the sex cells. Okay, the next question is about inhibin. What is inhibin? What produces it? What does it do? Make sure you know next week. Okay. Make sure you guys know the differences in these negative feedbacks. Inhibin only inhibits FSH. That is it. Okay? LH is on its own. So make sure you know that one as well for next week.
Is this one like a positive feedback or no?
Inhibin is not a positive feedback. It turns it off. That was estrogen. There's no testosterone. There's no positive feedbacks.
Oh.
It's okay. Okay, next one. Spermatogenesis occurs where? Okay, the question's asking for where does spermatogenesis occur, not where they mature. Because where they mature is different than where they're created. Okay, seminiferous tubules is where they're created, then they get stored in the epididymis where they mature until they are released. Well, I gave you the answer, so I hope you listened. So. What does seminal vesicle and prostate do?
Transport that?
They just add stuff to the semen. They just add fluid to the semen collection as the sperm go along the tubes. Okay, good. This is the... Okay, next question. The follicular phase of the ovarian cycle coincides with which phase of the uterine cycle? Okay. When it comes to phases, remember the ovarian phase has the follicular phase, ovulation, and the luteal phase. The uterine cycle has the proliferative phase, the secretory phase, and the menstrual cycle as well, the menstrual phase. Those are uterine cycle terms and phrases. The ovarian cycle, luteal, follicular phase, and ovulation are all ovarian cycles. So make sure you know that while the ovarian is in the follicular phase, they're maturing those eggs, they're getting them ready to ovulate. The uterus at the same time is undergoing proliferation, getting more vasculature to the lining, getting the lining a little bit built up and fluffy, waiting for that fertilized egg to arrive. So make sure you know which phases go with what. Below a given threshold, what does estrogen do? So normally estrogen, we learn about it. It has feedbacks. So below a given threshold, what does estrogen do? Okay, just like testosterone, estrogen is produced by the gonads and it has a negative feedback at the anterior pituitary hypothalamus. However, during the follicular phase, those theca cells that surround the ovum, the egg, mature and they start making a ton of estrogen as well. But until you get above threshold, it's a negative feedback. But when you get above threshold, that causes the LH surge, which then causes the ovulation to occur. So below threshold, estrogen is a negative feedback, but once it gets above threshold, that means that that egg is now mature enough, it's ready for ovulation. Now, the estrogen provides a positive feedback on luteinizing hormone, causing that LH surge, and ovulation begins. Okay, ovulation occurs when? Okay, day 14 is a generalization. On average, in a 28-day cycle, ovulation does occur at day 14. However, it can become between like days 11 to 16 or 17, anywhere in that little window. We don't know for sure, but obviously you can do ovulation test kits, and they'll tell you exactly when you're starting to ovulate. Towards the end of the luteal phase, by that phase, what happens at the end of the luteal phase if there's no fertilization? Menstruation begins because there's no HCG keeping that little corpus luteum alive. So the luteal phase ends because the corpus luteum dies off. Nothing is keeping that corpus luteum alive anymore, so it dies off. 1 day before menstruation, that's not when ovulation occurs. And obviously, it responds to the LH surge, and that's why you get ovulation. Okay, if fertilization and implantation successfully occur, what happens next? Okay, good job. Ovulation will continue every 28 days. No, we suppress ovulation because you already got pregnant. We don't need another egg to go, so we stop it all. Corpus luteum becomes the corpus albicans. That happens when you don't have fertilization. And menses is triggered. No, the opposite is true. It doesn't happen because now we have a fertilized egg. Okay, which layer of the uterine wall faces the uterine cavity? So what is the innermost layer of the uterus? Okay, very good. And we got that one. Okay, fertilization is most likely to occur where? Okay. Guys, listen up. We'll talk about it. So, in the uterine cavity, fertilization does not occur in the uterine cavity. Implantation occurs in the uterine cavity. The blastocyst implants itself in the uterine lining to form the placenta. But fertilization of the egg occurs in the ampulla of the fallopian tubes. That's where fertilization occurs. Not in the cervix. The cervix keeps the uterine closed off, and obviously not in the isthmus. So, okay, this is another question about FSH. So what does FSH do? Okay, this does help the growth of the follicle. Now, what induces ovulation? LH, not FSH. LH induces ovulation. What induces menstruation? What causes that? It's not an increase of anything, it's a lack of progesterone. The lack of progesterone coming from what? Corpus luteum. When that corpus luteum dies off, due to why? Why would the corpus luteum die off? You're not pregnant, there's no HCG keeping it alive, so it dies off. So your progesterone levels drop. When they drop, all those vessels shrink, constrict, no more blood supply goes to the lining, it can't survive without blood supply, and it sloughs off, and menstruation begins. That's why if you're on birth control pills and you don't take it the same time every single day and you're late, you may get a little bit of spotting because your progesterone drops slightly. That's what induces the spotting. That's why I gotta take it the same time every day, so your progesterone levels stay up. Okay, next, moving on to endo now. Catecholamines. Okay, catecholamines. What are the two catecholamines? Epi and norepi. Okay? Epinephrine, because they're an amine group, they're not steroids, they're amines. And have a slow response time but prolonged effect? No, those are hormones. These are, or catecholamines, but they have a fast response time, short effect. So think of like fight or flight response. It only lasts for a little bit, and once it wears off, you crash hard. It doesn't last very long. Okay, so they're released by the medulla. Okay, which of the following statements are true? Peptide hormones are stored on demand. Prohormones bind directly with nucleus. Carrier proteins transport peptides to the target. And peptide hormones bind with surface receptors. Okay, so a lot of people picked yellow. So carrier proteins transport peptides to target. If you talk about carrier proteins, what are you essentially saying about the hormone itself? Is it water soluble or lipid soluble? It's lipid soluble. It doesn't like water, so because it's lipid soluble, it got to bind to a protein to get around the blood. Peptides are water-soluble hormones. They go right in. They don't need a carrier. They go right through. Steroids, thyroid hormone, those need carrier proteins to get around. All the other ones really don't. But peptide hormones bind to surface receptors, triggering those secondary messenger systems. So make sure you remember the secondary messengers that they can influence. And what do secondary messengers do? Amplify the signal that these peptide hormones bind. Yes?
So which one is stored on demand?
Those are your steroids. They make them only when you need them. And then everything else is made and stored in vesicles waiting for release. Yeah, I think it's a form of one. But I don't think it requires a carrier. It might not be a peptide hormone. I think it's a separate class by itself. Okay, a suckling infant will promote what? Okay, test taking skills. One of these answers is not like the other three. Yeah, so not all of them. One of them is not, but the other three are. Yes. Oxytocin for the milk let down. What hormone creates the milk? No. Pitocin is oxytocin. Prolactin makes the milk. Okay, which of the following is true? T4 is more biologically active than T3. T3 is more biologically active than T4. T4 is converted to MIT. T4's overproduction occurs in hypothyroidism. Okay, so thyroids. Remember, there are two thyroid hormones, T3 and T4. T3 is the more metabolically active one compared to T4. However, when you draw labs, which one's going to be more available in the body? Which one's higher concentration? T4 is higher concentration. It is converted to T3 in the tissues in the periphery to make more T3 later on, but T3 is a more biologically active hormone with regards to thyroid hormone. And then the green one, if T3 or T4 is elevated, that means you have hyperthyroidism, not hypothyroidism. Okay, inhibition of angiotensin II would directly affect hormonal production in which region of the adrenal gland? So what region creates what hormone is going to be affected downstream from this? So which zone makes aldosterone? So this is a know it or you don't know it. There's really no way to think through this one, but you got to know which zones make which hormones. Okay. When you are studying this section, make sure you know what zone, the hormone, and the enzyme that's present in that zone causing that one to be made. Obviously, it's glomerulosa, it's aldosterone synthase is the hormone, enzyme to remember. That's why it's present in that area, that's why it makes aldosterone. And make sure you know, what is the fasciculata, what does that make? Cortisol, reticularis, androgens, very, very weak androgens. And the medulla, what does that make? Your catecholamines. Okay, we already went through this one, but hopefully you're paying attention. Oh, the order? That's a good one. Salt, sugar, sex. Okay. Okay, what's special about vitamin D? Is it activated by osteoporosis? Decreased phosphate absorption from small intestine? Activated when blood calcium falls? Or activated when phosphate concentration increases? So in this section with calcium, What are the two major hormones we got to know for calcium metabolism?
Vitamin D and PTH.
Vitamin D and PTH. Okay. Vitamin D is activated when calcium falls. What does vitamin D do? There's two things. What one system does it attack and help with? Bone. But what does it do? Not really the bone. Vitamin D tells the small intestine to absorb more calcium, and it tells the kidneys to excrete less calcium so that more calcium stays in the blood. So that when it builds up, what hormones get released when calcium levels are too high? Or they're low, also PTH, but we want to put that extra calcium into the bone. The bone is just a reservoir, and when calcium levels rise, we just dump it in there. But when it drops, PTH, vitamin D get activated. So make sure you understand with PTH and vitamin D how they interact. What are the consequences of PTH? Remember, PTH does two things to the bone. What two things happen to the bone? Degrades it, but what two things come out of the bone? Calcium and phosphate. What do we want to come out? The calcium. The phosphate we don't care about. That's why the PTH will also allow phosphate to leave the urine faster, because it's building up phosphate. We don't need the phosphate, so we have to get rid of it. The calcium is what we want. We want the calcium to stay in the blood. The phosphate doesn't matter, so we have to get rid of it. Okay, somatostatin. Okay. Remember somatostatin, stop. Remember that. What's secreted by the beta cells? Insulin. What's secreted by the alpha cells? Glucagon. What's secreted by the delta cells or D cells? Somatostatin. Someone said it. Somatostatin is the D cells. And everything else is fine. So how does glucose enter the beta cell? Okay, there was a picture. It had a big circle that had the beta cell, and the top part was little passive transport pore for glucose, and it goes directly into the cell. So that's why when you eat something, it's a one-to-one. The amount of glucose that you eat, that glucose will stimulate the appropriate amount of insulin to handle that carbo load that you just ate. With type 1 diabetics, they calculate out how much insulin they need to give themselves based off of the carbs they're about to eat. So they match the amount of carbs. It's a one-to-one, very, very close relationship. But glucose enters the beta cell via passive transport. GLUT4 receptors are in the muscle. So that after exercise, these GLUT4 will grab glucose by themselves without the use of insulin and bring glucose in. GLUT2 receptors are in the brain. So that's where there's different GLUT receptors. But beta cell glucose is just passive transport. Okay, glycogenolysis or glycogenolysis. So lysis is breakdown, so immediately 2 answers are gone. Just go to the breakdown question because it ends in lysis. It has to be breakdown. Okay, the red one, glucose is formed from non-carbohydrate substances. What's that known as? Gluconeogenesis. It's a new glucose formed from something else. Formation of glycogen from glucose. Glycogenesis. Breakdown of glucose into ATP. Glycolysis. Okay, bringing back your biochem flashbacks. Right? And then breakdown of glycogen into glucose is glycogenolysis. Okay, next question is about insulin. What is the main goal of insulin? Reduce blood sugar. That's all its job is. So when you're answering any question about insulin, just think, what is going to take the glucose out of the blood and put it somewhere else? Which of these answers go along with that? And process storage of glucose as trigs. That's why if you eat a lot of carbohydrates, you gain fat because insulin is going to put it as fat. Reduces skeletal muscle uptake of amino acids and protein. No, it increases that. You're getting the sugar out of the blood. Also protein. Remember, insulin is going to promote protein growth. Inhibits sodium potassium pump activity. Nothing really to do with that. And it's released from beta cells in the pancreas, not the alpha cells. Okay, insulin promotes. So again, keep that in your mind. Getting glucose out. Okay. Protein degradation and amino acids into the bloodstream are the same thing. If you degrade the protein, the amino acids get dumped into the bloodstream. Insulin does not promote protein breakdown. It promotes protein synthesis. Remember, like insulin growth factor. These insulins make things bigger. Movement of K out of the cell? Nope. Insulin is a treatment for hyperkalemia because insulin will push potassium into the cell. That's just a separate thing that insulin does. It doesn't move it out of the cell, it pushes it in. So the only one that makes sense here is protein synthesis. And we have our last question. Last one. Dopamine will inhibit which hormone from the anterior pituitary? Okay. What inhibits TSH release? T3 and T4. Know your feedbacks. What inhibits growth hormone? What? On growth hormone? IGF-1. Okay, IGF-1 has a negative feedback for growth hormone. ACTH. What is the negative feedback for ACTH? What does ACTH create? Cortisol. So cortisol provides the negative feedback for ACTH production. Prolactin, dopamine inhibits prolactin production. So make sure you know all those hormones. There's 5 in the anterior, 2 in the posterior. Know those negative feedbacks. Okay. Any remaining questions about this last unit exam? Test next Wednesday. I'll do the review on Tuesday night again. Otherwise, you guys are done for the day. Enjoy the rest of your day.